This is the study guide for section 2.1. It's on real numbers and number lines. It gives you a lot of information about sets of numbers. They tell you what whole numbers, integers, rationals, irrationals, and real numbers are. It gives you examples of each. So this is a good place to refer back to. This in your notes would be a great place. This might actually be a little bit better because it's all in one spot. Okay. For each situation, write a real number with 10 digits to the right of the decimal point. So we did some of these in our lesson. The number one asks you for a rational number between 5 and 6 that terminates. Remember, that just means ends. Between 5 and 6, you could start with 5 point something. You need it to be rational, but since it terminates, that automatically makes it rational. This decimal terminates because it stops. Now, even though there's nothing over here, I think you know what comes next. Remember, you could fill these all out with zeros if you wanted to. Number 2, this time we want to make an irrational number, and we have to make it in between 1 and 2. So 1 point something is a good start. To make it irrational, you don't want it to terminate. You want it to be non-terminating. Goes on forever. Also, you can't have a pattern, so you need a bunch of random digits. It says 10 to the right of the decimal. Something like that. There is no pattern here. The ... means that this is going to keep on going. That's what makes it irrational. Number 3, you need a rational number in between -3 and -2. If you struggle with that, here's a number line down here that could help you. Here's -3 and here's -2. Some number in here would start as -2 point something. A lot of people struggle with that. You want it to be rational, and it says 3-digit repeating pattern. This repeating pattern forces the number to be rational. So just pick 3 digits and repeat them. So I repeated 715 over and over. I know that's not 10 digits to the right of the decimal, but I think you know what comes next. It's rational. Okay, this bottom section gives you a number line, infinitely many points on a number line. Some of these points have names, and they have coordinates as well. It's always a good idea to know what your scale is on your number line. Every time you make a move, are you counting by ones? Are you counting by twos? Are you counting by fives? Are you counting by halves? That's important. Okay, so from this spot right here to this spot, I didn't go from -9 to -8. I went from here to here. Each little move is a half. Okay, maybe you would understand better on the positive side as well. If this is 0 and this is 1, obviously the thing directly in between it is a half. That's your smallest unit of measure. So if you're counting, that's how you can count by halves. Number 4, we want the distance from H to I. That's how you read that. How long is segment HI? H lives at 4, I lives at 7. What are you going to do with those numbers? This is your ruler postulate. You subtract them. 4 minus 7 gives you -3, but when you take the absolute value, you get +3. Remember, segment lengths need to be positive. If you wanted to count this distance, you could have 1, 2, 3. Sometimes it gets a little crazy counting, especially if you're counting by halves. I know that's a little bit tougher to see. That's all the more reason to use your ruler postulate. Okay, I'll just jump around and do a few of these. Maybe I'll do 2 more. Number 8, we want the distance from point B to point C. Point B lives at -6. Point C lives at this point, and there's no coordinate there. It's in between -4 and -3. Be careful there. Now, we have a negative and we're subtracting a negative. That's probably enough to confuse a good bit of us. You can use your calculator. That's okay. So I will use my calculator here. You want the absolute value, so I hit this math button right here. And I'm going to go over to the number part of the menu. That ABS is your absolute value. Notice how those vertical bars come up and I can type something in between. -6. Look where the negative button is. That's a negative, that's a minus. -6 minus -3.5. This kind of takes all of the brain work out of this. You don't have to actually think about this. You can just type it in. And it's going to tell you that the distance between those points is 2.5. If you wanted to count, you could. 1, 2.5. Same answer. Let me take a second and look at this and see which one might be the trickiest one. I'll look at number 10. We're going to go from C to J. C lives at, be careful, we just did it over here as well, but it's -3.5. J lives at +9. Those are your coordinates. We want to subtract those. So you have a negative subtracting a positive. Again, that might give some of you issues. You can just type it in. If I hit second enter, the same expression comes up, and I could just change my coordinates out. -3.5 minus 9. I have an extra character, so I'm just going to delete it. DEL. And that gives you a length of 12.5. Again, it's got to be positive. If you did this in your head, maybe you thought it was 5.5. But if you look at the segment up here, segment CJ is a little bit bigger than 5.5 units. Hopefully you realize that, and hopefully you don't let that mistake be your final answer. Okay, you can count again if you want to, but counting 12.5 spaces by halves is a little bit of a challenge.